Okay, so today I'm going over Module 9.1, Explain 2 and Explain 3, and I'm starting on page 427. So Explain 2 says identifying the LCD of two rational expressions. So let's look at what the LCD is. So given two or more rational expressions, the least common denominator, or the LCD, is found by factoring each denominator and finding the least common multiple of the factors. This technique is useful for the addition and subtraction of expressions with unlike denominators. So the steps that the book outlines for us is to find the LCD of a rational expression. You're going to first factor each denominator completely and write any repeated factors as powers. Then step 2 is to list the different factors. If the denominators have a common factor or common factors, use the highest power of each common factor. So I'm just going to give you a quick example of what that would look like. Let's say the denominator of this one was x, and we're adding it with, let's say 4 over x squared. So the common factor here is x, right? This one is x, and this one's just x times x. And so it says use the highest power. So the one that we would use as our lowest common denominator would be the highest power, which would be 2. So our LCD of this would be x squared, not x, but x squared, because that's the highest degree. Now we're going to use this in example 2 here, and it says to find the LCD for each set of rational expressions. And so part A they've worked out for us, where step 1 is to factor each denominator completely. And so this first denominator here, they took out a 3 from each of these. That was our common factor there, and they factored it. For this second denominator here, we have 4x plus 28, and they took out a 4 because there's a 4 in common between 4 and 28, and they factored it there. Now it says list the different factors. So step 2 is to list the different factors, and if we look at the different factors, we have 3, 4, x minus 5, and x plus 7, and so our LCD, or lowest common denominator, is when we multiply all of these together. So when we have 3 times 4, that's how we got the 12 here, and then the x minus 5 and the x plus 7 are right here. So there we've identified the LCD. So now let's see if we can use these same steps to help us do part B. Step 1, factor each denominator completely. So our first denominator here, we're going to go ahead and factor. And the first thing I checked for is there a common factor. Is there a number or a variable that goes into each of these terms? And there's not. So then I go straight to what is it that multiplies to x squared, which is x and x, and what multiplies to 24. And I want to keep in mind that it's going to have to add to 11. So I think of the factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And the ones that are going to get me to 11, I see are 3 and 8. And so I'm going to put 3 here and 8 here. And since I need a negative 11x, I know that both of these are going to be negative. For our second denominator here, I do not have any common factors. And so I ask myself again, what multiplies to x squared, x and x, and what multiplies to 9 but adds to 6? And I think 3 and 3. But since it has to be a negative 6, I know that both of these have to be negative. Alright, now it says to list the different factors. So the different factors that I have are, let's see, x minus 3 and x minus 8. And then for this one, I have x minus 3 squared. Right? And it says taking the highest power of x minus 3, which we said is squared, our LCD is going to be this multiplied by this. So I'm going to have this x minus 3 squared times the x minus 8, and that is my LCD. Now for your reflect, let's go ahead and look at that. So the reflect says, when is the LCD, or lowest common denominator, of two rational expressions not equal to the product of their denominators? So if we look in example A, we had 3 times x minus 5 times 4 times x plus 7. So one could probably say, oh, you just take all the denominators and you multiply them together, and that's how we got our LCD. Well, that's true for this one here. But if we look at the one in part B, we had x minus 3 times x minus 8 times x minus 3 times x minus 3. So if we just took all those and multiplied them together, then our LCD would actually have been x minus 3 multiplied 1, 2, 3 times, and then the x minus 8. So it doesn't work for this scenario here, right? So why is that? So let's say, when is the lowest common denominator of two rational expressions not equal to the product of their denominators? Well, it didn't work in this one because each of the denominators had the x minus 3, and in fact this one had it twice. So what we could say is the LCD is not equal to the product of their denominators when the factor appears one or more times in each denominator. Okay, or another way to think about this is if the factor appears in one or more of the denominators, that means that they share a factor. So we're going to go ahead and move on to explain 3, and I'm going to leave the your turns on page 427 for you. So let's go to page 428 and let's look at explain 3. Now, explain 3 goes back to what our essential question of module 9.1 was, and it's how do you add or subtract rational expressions? So adding and subtracting rational expressions is similar to adding and subtracting fractions. And so I'm going to give a quick little 1/2 plus 3/4. Can I add these two fractions? Well, immediately we should think, well, no, not like they are, not until we get common denominators. And in order to get common denominators, I'm going to have to multiply top and bottom by 2, and I would get 2/4 plus 3/4. And now that I have common denominators, I can go ahead and add these and say that it's 5/4. So this is very similar to what we're going to see here in explain 3. So example 3 says to add or subtract, identify the excluded values, and then simplify your answer. So we are going to go ahead and do that with part A here, or go through what the book set up for us. So step 1 is to factor the denominators. So if I'm looking at this original, x squared cannot be factored, but x squared plus x can be factored, right? There's a common factor between these, which is x, and so if we pull out that x, we're left with x plus 1. And that's how we get this right here. So step 2, well, the directions say find the excluded values, so that's what we're going to do. We're going to identify where the expression is not defined. And if we remember, anytime the denominator is 0 in a fraction, we have a value that's undefined. So we're going to go ahead and set our denominators equal to 0 in order to find out where they're undefined. So for this one here, what values would make that 0? Well, when x equals 0. So x squared is 0 when x equals 0, and so that's one excluded value. For the second expression, we have x. Well, what value makes x 0? Well, 0. So x equals 0 is also excluded. Well, doesn't actually match the first one that we came up with. So let's see if there's any other excluded values. we have x plus 1, and if we set x plus 1 equal to 0, we would subtract 1 to both sides, and we would get x equals negative 1. So negative 1 is also an excluded value. And so we can say that x cannot equal 0, and x cannot equal negative 1. Now, for our common denominator, step 3 says find our common denominator, and the LCM for x squared and x times x plus 1, these are our two denominators, is, remember how we found our LCD, is taking the higher power of the repeated ones, which is x squared, and multiplying that to the other denominators that don't repeat. So write the expression with the common denominator by multiplying both by the appropriate form of 1. So let's think about this. If I want my denominator to be this, and my denominator is x squared, well, there's the x squared. What is it missing? It's missing that x plus 1 over x plus 1. And so, I'm sorry, it's missing the x plus 1. So in order to multiply by the x plus 1, we have to remember we have to multiply top and bottom by it. And for this denominator here, I want it to be x squared, and it's only an x on the outside there, so I know that I have to multiply by an x, and again, what you do to the bottom, you have to do to the top. So we're getting our common denominator, and now we're going to have to simplify. So if you think about it, we have this times this, and we have this times this that we have to multiply out, and the book does that for us in example A, where x times x squared is x cubed. They continue to distribute these and combine like terms, and that's how they got our numerator here. So after you distribute and combine like terms, now you have common denominators, so we can go ahead and add our numerators. So x cubed plus x cubed is 2x cubed, and we have nothing to combine these other terms with, so we just go ahead and write them. And we've now simplified and added, and this is our new answer. Says, since none of the factors of the denominator are factors of the numerator, the expression cannot be further simplified. So that's saying if something was on top that was also on bottom, right, we could reduce that out, but we don't have that. So moving on to part B, we're going to go ahead and follow those same steps where we factor our denominators. So factoring this denominator here, I can take out an x, and I'm left with an x minus 5. And looking at this denominator, I can't factor x squared. So let's find which values it's undefined for. So setting each of our denominators equal to 0, that's x equals 0, x minus 5 equals 0, and x squared equals 0. So we get x equals 0, x equals 5, and x equals 0, which we already have from this one here. So the values that x cannot be are 0 and 5. So that's x cannot equal 0 and x cannot equal 5. Let's find our common denominator. Our common denominator, we need an x minus 5, and we need an x squared. And since these are common factors, right, x squared is just x times x, we take that highest power, and we take the x minus 5, and that's what we need to make our denominators. So if this is what we're making our denominators, what's this one missing here? Well, it's missing another x, right, because we need an x squared. And this one here is missing an x minus 5. So we're going to go ahead and distribute these, and then simplify, which the book did so nicely for us here. And the last thing is that you have to distribute this negative. So this negative doesn't just go to the x cubed, but it has to be distributed to each of these. So a negative times a negative is a positive, a negative times a positive is a negative, and now I've distributed that. Once we combine like terms, we get 2x cubed minus x cubed is x cubed, and there's nothing to combine with those, so this is our final answer. Hope that made sense. Again, this is a video, so if you need to stop, rewind, pause, go ahead and do so. Good luck.